Okay, let's start by maximizing the perspective viewport, and first thing I'm going to do is I'm going to create a floor throw scene. So for that I'm going to go to the command panel, to the create option, create geometry, and I'm going to select a plane. And I'm going to draw that into the viewport. I want to be able to see what I'm doing at the moment, so I'm going to press the F3 key to toggle to wireframe mode. F4 will toggle, F3 will toggle between wireframe and shaded, and F4 will turn on wireframe when you're in shaded mode. So for now we'll just use wireframe, and you can see I've placed the ground plane in the scene. Now at the moment I'd like to have that placement to be a little bit more accurate, and you can see that it's not quite centered on the center of the world here. It's slightly off. So you'll notice at the bottom of the viewport you have the three transformation axes here, and if you change to rotation or scale, it will also show the current scale of the object, or rotation, whatever mode it is that you have your transforms in. So for now I'm going to put it back into transform mode, and you can see that the center of the plane is not quite in the center of the world. So I'm going to actually zero those values, so it's going to be x0, y0 and z0, and that will put the plane in the center of the world. And I can do that by right clicking on these spinners here. You can see if I move the spinner up and down by holding the left mouse button and moving up and down on it, it works as a normal spinner, and you can just dial up and down the values there. Oops, it's actually shot off there. There we are. That's brought it back. But as I said, we're going to zero the value, and you can do that by just right clicking on the spinner. So there we go, that's zero that value, and that's zero that value. So now our plane is set up to be in the dead center of the world. I want our plane to be a little bit larger, so I'm going to go to the modify panel, and you can see there are parameters here for the plane. The main parameters for the plane are its length and its width, which you can see at the moment are 140.282 and 141.093. They're sort of arbitrary numbers because, as you saw, I just drew the plane in the viewport, so I want to get something a little bit more accurate, so I'm going to select that number and change that to 500, and I'm going to change the width to 500 as well. And as you can see, it's scaled out from its pivot. The pivot stays in the same place and the object will just scale around it. I shouldn't really actually call that a scale, because what I've actually done there is change one of the creation parameters. So no actual scaling is involved. I've just actually made the ground plane 500 units by 500 units, rather than, say, creating it at 100 by 100 and then scaling up by 500% to make it 500 by 500. And those two things are actually quite different, which you may actually see later in the tutorial. So there we go, we've got our ground plane, and it's at the right scale that we want it for the rest of the tutorial. Okay, the next thing I'm going to do is I'm going to select the plane, right click on it, which brings up the quad box, and up in this part of the quad box you can see I've got unfreeze all and freeze selection. Because it's quite easy to select the ground plane while I'm working in the rest of the tutorial, and I don't want to do that until later when I texture it, I'm going to freeze it for now, and all that will do is it'll turn it grey, and I won't be able to select the ground plane from now on. So that's actually quite useful, so we're going to do that for now. Okay, there we go. The ground plane's frozen, you can see it's gone grey, and if I try to select it, you can see it's not actually possible anymore. Okay, so let's go back to the creation panel, and I'm going to create a box now. So select on the standard primitives box, and I'm going to make this box 4 by 4 units. So I'm just going to roughly do that by drawing on the grid. There we go. And now draw the height, and there we are, we've got our cube. Same technique, I want to center it in the world, so I'm going to right click on the transform values down here. That centered it in the world, and I want it to be exactly 40 by 40 units, so I'm going to type in the values here again. So there we go. That's great. Something I want to do as well is I want to actually have more faces on the cube, so that when I model the cube later, it's a bit more conducive to what I want to actually model. So I'm going to change the tessellation in each face to 4. There we go. So we've now got our tessellated cube, and that's ready to model in the next step of our tutorial. Okay, to continue, I need to convert this cube, which at the moment is a parametric object. And by parametric, what I mean is that I can click on the cube and I can change the tessellation values of the faces. I can change the scale of the cube. I can change these things at any time I want. Now, the only limitation with that is that to modify the cube, I would have to put a modifier on it by going to the list of modifiers and applying a modifier. And I don't always want to do that. Applying a modifier does have a hit on performance. So you really don't want to apply a modifier for absolutely everything. You only really want to apply them where they're needed. So it's actually possible to convert a parametric object into any other type of what I would call a primitive object in Max by right-clicking on it, bringing up the quad box, and at the bottom you see you've got a sub-menu which is called Convert To, and here you have options to convert to editable mesh, editable poly, editable patch, or convert it to a NURBS object. Now, I think it will pay to have a little bit of a description about what each one of these object types is. Editable patch and NURBS, they in themselves are actually parametric surfaces. That means that the polygons that you actually see in the viewport aren't necessarily going to be the same polygons that you'll see in a render. And both of these surface types are designed so that you can use quite a low tessellation in the viewport, and then at render time they'll both get tessellated to much higher levels to produce a much finer result during render. It could be said that when you see them in the viewport, all you're seeing is a polygonal representation of a mathematical surface, which is pretty much what they are. So in effect, if you change this cube into an editable patch cube or NURBS cube, you're actually changing it from one type of parametric object to another type. Editable mesh and editable poly are much more explicit. Editable mesh was the first type of polygonal surface which was implemented in Max and has been there since version 1. This was added to much later, I think it was in version 3 or 4, with editable poly, where the underlying engine that drove the polygons was changed and revised. And this allowed quite a few changes and improvements in the modeling system. By default, many of the modifiers in Max will actually convert a parametric object into an editable mesh when you apply them. So this must be borne in mind when you actually apply a modifier. This modification, though, isn't permanent. You can actually remove the modifier, and underneath that modifier, the parametric cube will still be a parametric cube. So this is part of Max's parametric and procedural workflow. Okay, so in this case, I'm actually going to convert this cube into an editable poly, and I'm going to change the tessellation back to 3 rather than 4. I think this will actually be better for what I have in mind. So I right-click on the cube, go to Convert, Editable Poly, and there we go. Immediately on the right-hand side of the screen, you can see that the parameters which were available for the parametric cube have gone. And let me actually undo that and do that again so you see exactly what happens. Take notice here that in the modifier panel it also says that it's an editable poly. And as you can see, as I said, the command panel over here hasn't really got quite enough room for the rollouts for this type of geometry. So I'm going to actually pull this window over here and customize it so that we've got 2 columns for the command panel. Okay, so let's undo what I've just done, and you can see it's gone back to a box. So in the modifier list you can see, rather in the stack window, you can see that we have a box, and if I convert it to an editable poly again, you can see it becomes an editable poly, and a plus sign appears to the left of it. If I click on that plus sign, you can see it shows that the editable poly has sub-object types, which is a common interface convention throughout Max, and is also used in modifiers as well. Now in this case, an editable poly is made up on the most basic level of vertices, and you can see that every face on the cube has 4 vertices. These vertices then are joined together using edges, so you can see these are actually edges here. Then you have a conceptual type of geometry in polyobject, which is a border. What a border actually is the edge of a polygonal surface. So if I had a hole here in the cube, a border would be the edges around that hole. And borders are generally used as an example. You may have a hole in a polygonal object, polyobject, and you may want to fill that hole as well. You can select the border and then use one of the polyobject tools to fill in that hole very quickly. So borders are more of a modeling tool than an actual fundamental part of a polyobject surface. What you actually see in the viewport are polygons, and you can see that this polyobject is made up of multiple polygons. You can see there's 9 per face of the cube. And those polygons are made up of edges and vertices. So those are the main types of geometry in a polyobject. Oops, I've just moved that there, so I'll just use Control-Z to undo that. Now, the last type is an element, and what elements are as an example, let's say you have a polyobject cube and you have a polyobject sphere, and you use one of the modeling tools to attach the 2 objects together. So in effect they become one mesh. Max will actually remember that there used to be 2 meshes, and each one of the sub-objects will become an element. So when you're in element mode, if you click on the cube, you can see it's selected the entire cube. And as it turns out with this particular object, there actually is only one element, so there's only one thing to select. But as I said, if it was modeled by attaching together multiple meshes, you'd be able to select each of the constituent meshes whilst in element mode. So there you go. As you can see, you can switch between each of the sub-object levels by clicking on the little branch here in the stack view, and you can do the same thing by clicking on these icons here in the control panel. So you can see there's 2 different ways to access that particular interface, and you can hit the minus button and that will close up that little menu there. One last thing I'll show you before I move on is let's go back into polygon mode. It's actually possible to convert a selection from one mode to another. So as an example, I've selected this face here, this polygon, and let's say I want to convert that into a selection of edges. I can do that by holding down Control and then clicking on edges, and you can see that it's gone into edge mode and it's selected all the edges that were making up that polygon. I can do the same thing, you know, I can move from edge mode into vertice mode, and you can see it's selected the 4 vertices of that polygon. If I change from, say, vertices into polygon mode, you can see that all the vertices that had polygons attached, they've selected the faces that were associated with those vertices. So it's possible to, as I said, to go between sub-selection types. So there we are, I select an edge and I convert to face, and it's selected the 2 faces that were associated with that particular edge. So that's a very useful tool when you're modeling. When you have a selection of faces and you want to use them, treat them as vertices, you can just hold down Control and change to vertices, and that selection will be carried over. Very useful. Okay, so in this case, I'm going to create a small plinth for a holy object, which I'm going to create later on in the tutorial. And what I'm going to do here is I'm going to use basic polymodeling techniques to create the plinth. So the first thing I'm going to do is I'm going to go into vertex mode, select the top vertices of a cube, and I'm going to pull them up. I'm going to translate them. There you go. Now I want to do the same thing for these vertices here, but it's much more difficult for me to select the vertices in the same manner as I did that. I mean, I could probably go like this and take a stab at it, but I may actually accidentally get vertices that I didn't intend to get. So what I'm going to do in this case, I'm going to go to edge mode, and I'm going to select one edge. There we go. And I'm going to use this tool here, which is loop. And I click on that, and you can see it's selected a loop of edges which runs all the way around the object. So I'll do that again on a different edge to show you exactly how it works. Select an edge and click on loop, and you can see it's selected a loop again which runs all the way around the cube based on the edge that I selected. This is a very fundamental thing when you're polymodeling. Very often you'll have a loop which is in a certain place on the mesh, and you want to move that. So you just select an edge and click on loop, and you've got the loop selected. I'll move that loop up, and I'll do the same thing for the next loop down. Move that one up as well, and there we go. The loops are now in pretty much the place that I want them to be. I'm going to scale this loop, so I'm going to press R to change to the scale gizmo, and I'm going to uniformly scale it, and there we go. I've actually tapered in our surface. Now it's going to be a plinth, so I want to create some kind of tabletop effect. So I'm going to select a loop of edges again and move this up here, and I would really like to produce a thinner part of the mesh here. So something I'm going to do now is I'm going to create a new loop that runs all the way around this object. To do that, I'm going to need to connect each one of these edges to the next edge along. Now, connecting edges in Max is very easy. You just select two edges like this, and go down to the connect tool here, and click on that tool, and it connects it those two edges together. You can see it's produced a connecting edge there. If I undo that with Control Z, if you click on the connect tool with the settings button to the side of it, which is something which was introduced in Max 5, you can actually choose the number of connections. So you could have as many as you want there, 6. I'm just going to 0 that. In this case you can't have 0 connections, so it'll go back down to 1, and we'll just OK that, and there's a connection. Now I want to connect all of these edges to create a loop, so I'll select this edge here, and in this case I'm going to use the ring selection tool, which is kind of a partner to the loop tool. And if I click on that, you'll see exactly what it does. So there we are, it's selected a ring of edges which run all the way around the object again. I'll do another selection again, so I'll select this edge here and then do a ring, and you can see you've got a ring selection. So those are the two main selections that you'll be doing using poly modeling, and they're very common. They're pretty much fundamental, so they're something that you have to get used to very quickly, and once you are used to it, you'll be flying along. So I'll select a ring, and I'll use the connect tool, and there we go, it's put in a loop which runs all the way around the object. I'll select that loop, I'll move it up so it's very close to the top of the table, and I'm going to create more of a lip here, pressing R and then scaling this down. So now we've got something a bit more of a table, a plinth I should say. I'm going to create the same thing for the base of the plinth. In this case I'm going to go for a fluted effect. So I'm going to select a ring again, connect it together, select another edge, create a ring again, connect it together, do the same thing again, ring, connection, and now I've got enough subdivisions here to be able to produce quite a nice fluting effect. So I'm going to do that now. Select this loop, scale that, select this loop, scale that down, and select this loop and scale that down as well. And there we go, we've got a sort of taper to the bottom of the table. Now I think it'd be nice to have some detailing maybe on the upright part of the table here, the plinth I should say, and I'd also like to make the top of the plinth maybe appear to be a little bit more cylindrical. So I'm going to select these edges on the corner, and the same for the next edges. I can add to my selection by holding down Control, and I'm just adding vertices to my selection there, and using the pan and rotation tools to navigate around the table. So there you go, I've selected all the vertices on the corner of the table. Now in this case, if I do a uniform scale, you can see that this will cause a little bit of a problem, because not only is it pulling in the edges of my plinth, but it's also scaling them vertically, which is something that I actually don't want. So in this case I'm going to use scaling just on the Y and X axis. If I just select this here and scale in, and you can see that it's just scaling on the X and Y, so the height of the segment is kept the same. So there we go, we've created something a little bit more cylindrical. Now I think that maybe the base is maybe a little bit too sharp edged, and I don't think that'll look good in the end, so I'm going to move the table up slightly. There we go, the plinth, and I'm going to select the bottom faces. Here we go, and I'm going to extrude that down slightly. So with extrusion you'll see exactly how it works here. There we go, I'm using the settings option so I can actually modify the extrusion. There we go, that's just about the height that I want, and then I OK that. And I'm going to use the same tool to actually create a little inset here on the four sides of the plinth. But before I do that, I want to keep a little bit of space between here and here. So I'm going to create two more loops. So I'm going to select the edges by just using the marquee. In this case I didn't use the ring tool. And then I'm going to connect, and in this case I'm going to use the settings to do 2. There we go. They're a little bit too low and a little bit too high, so I'm going to select the loop here, move that up into the right position, do the same thing here, select the loop, move it down. There we go. And now I'm going to do the inset, as I said. So I'm going to select these faces using Control again to add to my selection. Oops. Okay, there we go. Oops. There we go. So we've got the 4 faces. And in this case I want to both extrude and scale the extrusion. So I'll show you the difference. And in this case I don't actually want to do an extrude, I want to do a bevel. So I'll just quickly show you the difference between those two things. Let's do an extrude. And as you can see, the faces have come outwards. I'll put it into shaded mode so you can see that maybe a little bit more clearly. But I can quite as easily do a negative extrusion. But it's just as easy to do a negative value, and then the extrusion will go inwards. Now I could just OK that and then use the scale tool and make the scale local to each face. But you can actually achieve both those things by using the bevel tool instead. So I'll undo what I've just done there. We're back to our normal faces, and I'll use the bevel tool as I said. So I'll click on settings, change the height of the bevel to be negative. There we are, it's going inwards, and you've got an outline amount, and at the moment that's -1, so we'll change that to be a little bit more subtle. There we go. So I'll OK that, and now we have a little inset on the plinth, which is pretty cool. I'm going to do the same kind of thing for the top of the table to make it look a little bit more interesting. So I'll just select this edge here. Actually, something that's happening is quite frequently I'm selecting edges and vertices and so forth on the opposite side of the object, which can be quite annoying when you're modeling. So a quick way to stop that is to turn on the ignore back facing option, and basically any edges or faces or vertices that are not facing towards the camera won't be selectable. So that's actually quite a useful tool, so I'll just turn that on there, and that'll save me some misselections from now on. There we are, so I've selected that edge. I'll create a ring from that, and then I'll connect those and I'll keep it as 2 connections. That's cool. Then I'll select this edge and create a ring from that again. Just selected that ring, and in this case I'm going to do a scale, so I'm pressing R, and I'm going to scale them vertically. So I'm going to just grab on the Z-axis and scale it vertically, and then I'm going to do a uniform scale. But as you can see, it's actually scaling from this edge over here. So to get around that, I'm going to use a central pivot for my gizmo, and there we go. I've got my scale pivot right in the center of my selection now. And now I'm going to do a uniform scale, and that's scaled this out a little bit more on Z. And there we go, I've created a beveled surface to the table. Okay, what else shall I do? What else would be nice on this? Maybe to make the base of the plinth a little bit more interesting, I'm just going to select these edges here. Here. Oops-a-days. Just lost my view there. I got my focus back on my object. It disappeared off there for a second because of mouse zoom, and I zoom back on it by pressing the Z key, which will focus on whatever you currently have selected at the time. And there we go. So I've got those vertices selected. I'm going to do a scale, and I'm just going to scale on Y and X. And that will just, let's see what looks nicer, outwards or inwards. I think inwards maybe looks a little bit more interesting. So there we go. I think that looks quite good. Maybe no, I think that's okay. I think the only thing I'll do now is maybe make this bit here a little bit more interesting by pulling these vertices down here a little bit. I'm going to use Control to add to my selection. Make sure I haven't selected any vertices that I don't want to select. Yeah, that's looking pretty good. And I'll press W to transform and just move these vertices down on Z. So there we go. Actually, I'll do that a little bit more. I'll go back to get my selection, undo, get my selection back, move those down a little bit more. Select these edges here, do a ring, connect them. In this case I'm just going to do one. Select that looper there, and move that up a little bit. You can see it goes in a little bit here, which doesn't look so good. I think it'd be nice if it actually flared out a little, so I'm going to select that loop and do a scale, uniform scale. And there we go. There's our plinth. I think that's looking quite cool. I think we'll stick with that for now. Okay. Something to check now that I've modeled this plinth is the smoothing. The smoothing basically is Max's smoothing groups is Max's way of actually working out where blend shading or Phong shading should actually smooth together polygons to produce what appears to be a smooth surface. Now in this case I'm actually going to go for quite an angular look for this plinth. And you can see there are some sort of funny shadowing effects at the bottom of these edges here. That's actually caused by erroneous smoothing. It's actually trying to smooth from this surface here to this surface here. Effectively they're in the same smoothing group, and when faces are in the same smoothing group, the shading engine, both in the viewport and in a full render, will try and smooth between those two faces. Problems can occur when the angle between those two faces is too extreme. For instance, anything over 45 degrees may look a little bit strange if it's smoothed. So you can go into face sub-object mode, and in this case I'm just going to use the auto smooth tool to work out the smoothing groups for me. Now quite a decent angle to use is something around let's say anything between say 10 and 25. So we'll go for 18 and just give that a try. Actually, you have to select all the faces, so I'm going to use element to select everything, and then I'm going to do auto smooth. And now if I deselect the element, you can see that those shading errors have gone from the edge of the table, and I think that looks a lot better. Now where the angle is less than 18, the faces will be assigned to the same group, the same shading smoothing group. So this feature of Max is pretty robust, and it's quite a good way of fine-tuning the way your surface is going to render. So there we go, we've fixed the smoothing on the table, and that should render fine now. Okay, so we have our plinth, and the next thing we're going to do is we're going to put our holy relic onto it. In this case, this is a temple to the teapot, so our holy relic is a primitive, and here it is. Here's a little fella. Now I could create a teapot, let's say on the home grid. There's our teapot, and then I could use the translation tools to actually move it to the top of the plinth. But you can see it's not very accurate. I got that wrong there, and I might have to fiddle around to actually get that to appear to be just on the surface. Looking for the, you can see I'm looking for the lines of the teapot to just about disappear there to show that it's actually touching the surface. It's not a very fast workflow, is it? So a feature which is pretty cool in Max is you can use AutoGrid to basically create primitives on any surfaces that you have in Max. So I'm just going to get rid of this teapot, select it and delete it with the delete key. I'm going to click on teapot so I can create a teapot, and I'm going to turn on the AutoGrid feature, which you can see here. And now you'll see that when I move my cursor over the table, when it encounters polygons which aren't frozen, you can see that the tripod of my selection will actually conform to the surface. So this is probably best seen if I'm, oops, just undo that. If I just move down the surface here, you can see it's actually conforming to the surface. So if I choose a point on the surface and just click and draw, you can see Max is, actually it's not very visible there, is it? So let me just undo that, change it to wireframe mode, and do that again. You can see that Max is creating a grid in that place, which actually aligns with that face. I'll do the same here, same here, same here. So I've got a pretty crazy looking plinth now. I've got these teapots growing all over it, which is not really what I wanted. But it demonstrates exactly what this tool does. It's very useful when you're set dressing sometimes and you want to place things quite quickly. So let's just get rid of those teapots by doing Control-Z a few times to undo it. And I'm just going to go to the center of the plinth and create my teapot on there. There we go. So we've got our holy teapot. That's cool. Just turn off AutoGrid and go to selection mode so we don't create any more teapots. And the next thing I want to do is I want to have a copy of this plinth. I want to give the feeling that maybe at some point in the past this temple used to have more relics, and maybe it's a little bit ruined. So I'm going to create a second plinth, and I'm going to break it up into two parts. So to do that, I'm going to select this plinth, and you can quite quickly and easily copy objects in Max by holding down Shift and doing any kind of transformation, rotation, scale, whatever you choose. So in this case, I'm just going to move it over on Y-axis. It then brings up the clone option, and you can see that I can choose to copy it, instance it, reference it, and if I choose to change the number of copies, it will actually create more than one copy and will apply the transform that I've just done on each copy as well. So let's just show you that. And you can see I've just made a quick run of plinths there, mass-produced 8 of them, and you can see each time they've been transformed. So I'm just going to undo that. Now you would have seen there are other options. As I said, there wasn't just copy, which will just create a simple copy of the plinth, but there's also instance, to instantiate or to create a reference. So I'm just going to quickly show you what those two things do. So I'm going to create one instance, and I'm going to get this one, and I'm going to move this over here, and this one is going to be a reference. And to show you what the difference is between instanced objects and reference objects, I'm going to put a twist modifier on the main table, on the main plinth. So let's go to modifiers, let's go down to twist modifier, apply it to the table, and you can see that all three plinths have now got the twist modifier on it. Now the interesting thing is that twist modifier is actually instanced to each table because it's brought along by the instancing. Now what I'm going to demonstrate to you here is that referencing is a kind of instancing, but what it does is in comparison to an instance is at the point that you reference the object, the instancing stops. So in this case the table is sorry, the plinth has been instanced and the modifier gets passed on to the instance here, and the same thing happens here. It gets passed on because it's on the original plinth. Now if I change the parameters of this twist modifier, you can see that all the tables get modified. So that's quite a useful tool. It means that you can create one plinth, and then you can very quickly populate a scene with hundreds of plinths. And then if somewhere down the line you think to yourself, oh God, the plinths really should have some addition made to them, it's very easy to apply a modifier, do something to the plinth, and that modification will be applied to all of its instances, and also all of its references as well. So what is the difference between an instance and a reference? Well, to show that, I'm going to apply a taper modifier to this reference. So let's go down to modifiers, taper, and you can see that this modifier has only actually been applied to just this reference. I'm going to modify the taper, so let's make the top of the plinth much smaller, and let's change the curve. Let's make it a little bit larger again. So there we go. We've made quite a major change to the top of this plinth, and I'm going to go to the original plinth and change the twist so it's a bit more dramatic. And you can see that the twist modifier is applied to the instance and the reference, but you can see that the modifier which was applied to the reference isn't applied to either the original or the other instance. And that's because from the point that this plinth was referenced, it effectively took on a new branch to its history. So the thing about instances is that they will share everything. Each instance is the same as all the other instances, but the difference with a reference is that it's exactly the same as the parent that it came from, up to the point that it was actually created, and from that point on it's unique. Any other modifiers that you apply to the reference will only apply to the reference, but any modifiers that you apply to the original will be applied to both the original and the reference. So that's actually quite useful. You've got a choice of having the history being exactly the same on all instances, or you've got the chance of having a branching taking place by using references. So as an example, we'll put a bend on this instance, and don't forget this instance is exactly the same as this instance, so any modifiers that we apply to it get to apply to all instances. So I'm going to put a bend modifier on here and change the values in it, and you can see that it gets applied to this object because they're instances, and this object because these two objects share the same history. This shares the same history, but it branches after the creation point. So quite a lot of flexibility there. Very powerful architecture. It's also very robust. The instancing in Max is very functional, doesn't really have any bugs, and it's very advantageous to use it when you're rendering, because effectively in terms of computer memory, 4,000 instance tables is just one table. So it's a very cool feature in terms of memory usage and animation capabilities, and also scene layout optimization. Very cool tools, and something well worth exploring there. Okay, so I only actually want one table, so I'm going to get rid of this reference. I don't want the tables to be deformed, so I'm going to get rid of the modifiers. So I'm going to get rid of the bend, and I'm going to get rid of the twist. I'm going to modify this plinth. I'm going to damage it. So I don't want the original to be damaged as well, and because they're instances, that will actually happen. Any modifications that I make to this table, this plinth will happen to this plinth. So just to demonstrate, if I grab the vertices and move them around, you can see they're both getting modified, and I really don't want that, so just undo that modification. So if I want to make this plinth unique, there's a button here you can see right in the middle, and this will actually make any object that you use this on unique. So that will actually break the connection between the two tables, and from that point on, that particular table will not be an instance of its siblings. So let's do that. And it's now unique. Okay, what I'm going to do now is let's modify this plinth to make it damaged. So let's go into sub-object mode. I'm going to select this edge here, create a ring. I'm going to connect that ring together. I'm going to select the vertices of this ring. And what I'm going to do is I'm going to deform the surface. To do that, I'm going to turn on constraints edge, and that will stop. This will try and constrain these vertices to the edges that it's attached to, which is something I won't really dwell on here very much, but which will be shown in one of our other tutorials on polymodeling. Okay. There we go. So I'm just going to produce a kind of jagged edge there. Now, I want to break this table up into two halves, as I said. So what I'm going to do is I'm going to select all the faces in the top half. Using Control, I'll add to that selection. And you can see we're missing some here. Okay, there we go. We've got all the faces in the top half. We haven't got the ones on top. That would be a bit of an oversight, wouldn't it? Okay, there we go. We have all the faces. And now I'm going to get those faces and detach them. So let me have a look here where that particular tool is. There it is, detach. And it's asking me here, do I want to detach it to an element, which will, like I said, it's not really detaching in that case. It will actually keep it as part of the same editable poly, but it will turn it into a separate element. Let's do that just to show you how that works. Okay, there we go. And now if I turn to element mode and try and select the object, you can see it's now turned the plinth into two separate elements, but you can still see that they're part of the same editable poly. So I'm going to select the top half, and now I'm going to do a detach again. And this time I'm going to detach as an object. So I've done that. And now I've got two different objects. I've got the base of the plinth, and I've got the top of the plinth. And as you can see, I've got a jagged edge between the two separate objects. Now I'm going to change the pivot point of the top half. So I'm going to go to hierarchy, pivot, effect pivot, and I'm going to move it up on the z-axis, so the pivot is now in the center of the object. I'm going to do the same for the base, and I'm going to move that up to the center as well. There we go. So now their pivots are not at the base. And what I want to do is I want to actually cap this edge here, because at the moment it's just an open end. If I turn on shaded and move this up, you can see it's just an open end, and that's pretty ugly. You know, you wouldn't really see that in a real plinth. Our plinth is going to be made of stone, so you really wouldn't see, you know, paper thin stone. So we need to cap that end off. So I'm going to do that now. I'm going to go into border selection mode. This is what I was telling you about border earlier. We'll select any of the edges, and that selects the entire border. So now you can actually see what border does. We've actually got a border there. And I'm going to use the cap tool to fill in that border, and that will actually give us a nice clean end to the end of our table. So let's go cap. There we go. Got an end in there now. Go out of border mode, select the bottom half of the plinth, select border, and there we are, we have that border selected. Click on cap, and there we go, we have an end to the table. So there we go, that's pretty cool. We now have a broken plinth. Obviously it's hanging in midair, so I'm going to use rotation just to model that around a little and put it on the floor. So we'll go like this a little bit. We'll rotate it a little bit here to make it a little bit more organic. I'm just going to move it over here slightly, and then I'm going to put it down on the ground. There we go. That's pretty good. It's resting on the ground quite well. And then I'm going to do the same thing for this part of the table. Just rotate this round a little. Let's try and give it a nice flat face to lie on. There we go. And we'll move this over here, and let's rotate it around a little bit more. It should probably actually be resting a little bit more like this, and then let's try and place it on the floor and see if it sits correctly. There we go. You can see that's going through the floor. This half isn't, so it needs to be rotated a little bit more. There we go. Put it down onto the floor. Oh yeah, that's not too bad. That's pretty good. So there we go. We've got our fully formed plinth here, and we've got our broken plinth here. So we're getting a little bit more of a sort of ruined feeling. Now to add a little bit of sort of, you know, Indiana Jones glamour to the scene, I'm going to have a burning ball fly through the scene later and smash the teapot off the top of the plinth and knock the plinth over. So what we need is a cylinder, and that will become our rope. And on the base of that cylinder, I'm going to put a sphere, and that's going to be our flaming ball. And I'm going to add particles to it and try and get that to look a little bit like flame, to make it look a little bit more interesting when we do the final render. So let's create let's go to the creation panel, standard primitives, cylinder, and let's create a cylinder which is the right kind of dimensions for a piece of rope. So I'll make it quite thin, and then we'll make it pretty tall. Let's have a look at that. It's not too bad. It's maybe, you know, a little bit too thick, so let's turn off wireframe here, and let's make that a little bit thinner. There we go. And the height is, I think it's fine actually, but I'm going to move it up into the air. There we go. I'm going to rotate it round. I'm going to turn on angle snaps, which at the moment is set to 5 degrees. So let's just rotate that round. There we go. And I'm going to move that to the correct kind of height so that it gives a little bit of room for the sphere to be hung underneath. There we go. That's pretty cool. The last part is, it's actually got some subdivisions on its height. You can see it's got a subdivision there, but later I want to actually bend it to make it look a bit more realistic when it's swinging. So I'm going to give it a few more subdivisions in its height. So it's got 5 at the moment, so let's put that up to 15. I think that should be fine. The next thing I'm going to do is I'm going to actually put a geosphere on the base, on the end of this rope, and make it large enough so it actually hits the teapot and let's say grazes the table. So let's create geosphere, turn on auto grid. There you can see we're conforming to the cylinder. Go to the tip and create a sphere. Now you can see at this point it's actually creating the sphere, and the pivot of the sphere is actually in the center of it. I don't actually want that. I want the pivot of the sphere to be at its base. So I'm going to turn on base to pivot and do that again. There we go. And that's actually much more like what I want. The scale, the radius isn't quite there yet, so I'll modify that. And there we are, just about hits the plinth. I think that'll be just about right. Turn off auto grid, and we'll make it a little bit more detailed. We'll increase the segmentation, so it's a little bit of a better sphere. And while I'm at it, I'll do the same thing for the teapot, because at the moment it's actually quite crude segmentation on it. You can see I'm having problems selecting that teapot, so very quickly I'm going to freeze that sphere, select the teapot, and increase the segmentation as well. There we go. So that's actually a much nicer teapot. I'm going to go to the display panel now, and using the freeze options, I'm going to unfreeze by hit. So click on the sphere, that's unfrozen, and there we go. So cool, we have the basis of our scene, and now it's actually time to move on to our next section, where we will apply modifiers to our objects and actually animate the scene.